I'm going to go over what you did yesterday. So this is our Friday lesson. So if we would have had a Google Meet yesterday, which I know we didn't, but if we would have gone over these green pages that you worked on Thursday. So I want to go over them now. If you haven't done the green pages yet, please go back and do those. This is a review over your commutative and associative property. After we review the green pages, then we're going to go ahead and start on the distributive property, which is your Friday's assignment. So let's look at what you did yesterday. We're using order and grouping, and there's a good example there of how order changes the way a picture looks, but it won't change your product or your answer. All right, let's do number 21 together. 21 says there are 2 classes of 3rd graders. In each class, there's a clue word. There are 3 rows. Rows is, of course, a clue word of desks with 7 desks in each row. There's our column. Each again is there as a clue word. Write a multiplication expression to find the number of desks in both classes. Show how to group the factors to find the product. Then write the answer. So we've got 3 factors going on this problem. We have 2 classes. We have 3 rows. And we have 7 columns or 7 desks in each row. So we have 3 factors. Now, I kind of like how they are grouped because they're grouped from the smallest factor, 2, then 3, then 7. I always like to put my small factors together. And so then I'm going to put them in a specific order. Remember, parentheses is the order that tells us what we need to do first. So I'm going to put parentheses around the 2 and the 3. I always like to group those smaller factors together because they give us a smaller answer to work with. So now we're going to solve it. 2 times 3 is 6, and 6 times 7, we're working on our 6's, so hopefully you spouted that answer off really quick. 6 times 7 is 42. So our question was, how many desks? There are 42 desks. Hopefully you got that answer right. This is the associative property because we were grouping them. All right, let's move to our next green page, which is number 21. This is page number 17 that you worked yesterday. Let's check this answer. It says AJ needs to solve 3 times 8 times 2. So 3 factors. Show one way to find the answer. Use parentheses to show how you group the numbers. Okay, I don't like how this is ordered. How do you think Miss Coleman's going to want them ordered? From what we just did. Yeah, I'm going to want to put those 2 small factors together. So I'm actually going to reorder this. I'm going to use the commutative property, and I'm going to put them in a different order. I'm going to put the smallest factor first, which is 2. I'm going to put 3 in the middle and 8 at the end. The commutative property says I can do that. Now I'm going to group those 2 small factors together. And I know 2 times 3 is going to give me the answer of 6. And 6 times 8. Again, I hope you spouted that answer off really quick because you're practicing those 6's. 6 times 8, the cake is 48. 48 would be my answer. Now, what if, Miss Coleman, though, I didn't do mine that way. I put 3 and 8 together first. Or maybe you put 8 and 2 together first. That's fine. You can do that. Remember, we can change our order. We can change our groups. I just prefer personally to put those small factors together because the smaller the numbers are, the smaller my product is. And it just makes it easier to me to get those answers. All right, let's go on. But no matter how you did it, everybody should have got the same answer. Your solution should all be the same. Everybody should have got 48. All right, let's look at number 23. Let's see if you got that one correct. 23 says Matt knows 4 times 6 is 24. I agree with Matt. What other math fact does this help Matt to remember? Does it help me remember 6 plus 4? No. Does it help me remember 8 times 3? No, that's not the same factors. What about 24 take away 6? Does it help me with that? No. What about 6 times 4? Yes, because why? Those are the same factors. This is the commutative property. All we did was switch the order. Sadie picked A. Let's erase and look back at A. She thought A. How did she get A? Why did she think that that's going to help us with 6 plus 4? Well, it's because it's the same numbers, isn't it? She saw the numbers 6 and 4, but she didn't match the answer of 24, did she? She got the same two factors. She also picked addition instead of multiplication. But what happened is she was in a rush. I know what happened because some of you do this. She saw 4 and 6. Oh, look, 6 and 4. That's what we're doing. We're using 6 and 4. But she doesn't need that 10, does she? She needed 24 instead of 10. Okay? Let's go on to your next screen page. Now, it starts back at number 1. This is the practice page. So you had 5 problems to practice on your own. Let's go over and check those and make sure you got all of those correct. Number 1 is about Jackson. Jackson knows that 9 times 7 is 63. He needs to solve blank times 9 though. So look what happened. 9 was first, now it's second. They both equal 63. What number needs to go here? This is the commutative property, by the way. We're missing that 7, aren't we? We had a 7 here. We need a 7 over here. Commutative property, you have to use the same factors. You're just moving them around. Number 2, which of the following is not, pay attention to that word, not true? So A says 3 times 6 times 3 is the same thing as 6 times 3 times 3. Both sides have a 3's. Both sides have 6. That's correct. They're using the same factors, aren't they? They just moved them around. So A is true. We don't want the trues. We want the not true. So we're going to eliminate A. Let's look at B. They've got 3 times 6 times 3 is the same thing as 9 times 3. Well, I see a 3 here. I see a 3 here. Then they've got a 9. Can I get a 9 out of those two numbers? I can't, can I? I can't get a 9 with a 6 and a 3. So I'm not so sure about B. I'm going to put a question mark next to that one. I don't think that'll work, but let's check the others. Look at C. I see 3 times 6 times 3 is the same thing as 9 times 6. Okay, I see the 6. I see the 6. Now, we have a 3 and a 3. Can I use 3 and 3 and get 9? Yeah, because I know 3 times 3 is what? 9. So this one is correct. So we're going to eliminate. That one's correct because 3 times 3 is 9. Remember, we can switch our orders around. We could do the 2 3's first. Look at D. 3 times 6 times 3 is the same thing as 3 times 18. Okay, I see a 3 and a 3. Then we've got 18. Can I get an 18 with 3 and 6? Yeah, 3 times 6 is 18, isn't it? So this one would be correct. So the one that doesn't make sense is B. Let's look at B again. B said you can get 9 times 3 with these factors. If I take this 3 out that they've already used, is 3 and 6 going to equal 9? No, 3 and 6 is 18, not 9. So which one is not true? B. B is not true. You had to think about your commutative property and your associative property there and how we can group numbers together. This is an excellent question that you might see on your state test. You might want to really go back over that one. All right, let's go to number 3. Number 3, we've got a service group here making sandwiches, doing some community service here. 7 children in the group. Each clue word is making 5 sandwiches. You need 2 slices of bread to make a sandwich, don't you? What's the total number? So we have 3 factors here, 7 children, 5 sandwiches for every child, and 2 slices of bread. And we've got to buy the bread, so we need to know how many slices we need. So 7, 5, and 2. I'm okay with how this is grouped. I'll tell you why. Because the two small factors are together. So I'm going to leave my order, not groups. I'm going to leave my order alone. I'm not going to change my order, but I am going to put 5 and 2 in parentheses because I want to do that first. You may know why. They're the small factors. And 5 times 2 is what? 10. And boy, 10s are easy to multiply, aren't they? And what's 7 times 10? 70. So we're going to need 70 slices of bread. Hopefully you found your 3 factors there and you were able to figure out what's the best way to group them together and get the answer 70. Even if you did 7 times 5 first, you got 35 times 2, still going to give us 70. So don't count it wrong or change it if you did groups different than Miss Coleman. Just make sure that your final answer matches. Let's look at number 4. We've got 2 more problems here. Lynn's mom has pictures arranged on her refrigerator in rows. There are 3 rows of pictures. There's clue 1, 3 rows. That sounds like an array to me. There are 7 pictures in each row. That's my columns right there. Which of the following expressions or arrays, didn't I tell you that sound like an array, could be used to find the total number of pictures? So we have 3 and we have 7, and we know it's rows and columns. Automatically, I see A uses my 2 factors, and it's also in a multiplication there. Look at B. What happened to B? They switched the numbers, didn't they? Can I do that? Sure. We can swap these around. That's the commutative property, isn't it? We can switch the order. What about C? Can I have 7 times 7 times 7? No. If those had been plus signs, third graders, we'd have to pick it because this means 3 groups of 7, doesn't it? But those are not plus signs, so C is out, 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 out. No plus signs. Look at D. Let's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Can I have 7 rows and 3 columns? Yes, I can, because the commutative property says we can. Look at E. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Can I have 3 rows and 7 columns? Yes, that's the commutative property, isn't it? So A, B, D, and E. The only one that doesn't work is C. C should not have been chosen, but the other 4 are all going to get us the same answer. We can use either one of them to find the total of 21. All right, last one, number 5. Also number 4, those are also good test prep questions that you'll see on your multiplication test with properties. Number 5, Dan has 2 photo albums. Each, clue word right there. Photo album has 8 pages. Dan can fit 4 pictures on each. Again, clue word. How many pictures can Dan fit in the albums? So we have 2. That's our first factor. 8 and 4. And of course, each tells us to multiply all of those together. Miss Coleman doesn't like that. What's she going to do? Anybody? Now I'm going to rearrange it. I'm going to put the small factors first. I want those to be together. So I'm going to reorder mine using the commutative property. And then I'm going to use that associative property and put 2 and 4 in a group. 2 times 4 is 8. And 8 times 8 is 64. Picture for that one, I don't know that we've done that one before. Those are always snowmen, and they're both outside, and they're kind of cold because, you know, they're snowmen. They're out in the snow. So the 2 snowmen look at each other and say, you know what we need? We need some sticks for our fire. Sticks for sounds like 64 to me. So 64 is 8 times 8. All right, so that's your green pages that you did yesterday. I'm going to come over here to my computer real quick. And I'm going to switch to today's work. So hopefully you checked all those and you got them correct. And if you missed any, you have changed your answers. So we're going to move on to lesson 3, still on multiplication, but we're going to be working with the distributive property. And I'm going to go over 4 pages with you. So I need you to be in your iReady book. It should be a blue page. You should be looking at some carrots. It is page number 20. It says lesson 3, split numbers to multiply. So this gets us to our distributive property. Ty has 6 bunches of carrots. There are 3 carrots in each bunch. How many carrots does Ty have altogether? Now, I know you know your 6's. You've been working with your 6's, but what we're fixing to learn is if for some reason you didn't know your multiplication facts of 6, you could break these numbers up into smaller factors. We talk about that Subway sandwich a lot and how you can't finish a foot-long sandwich in one bite. You have to do small bites. So sometimes in multiplication, when we're given a great big huge number, we want to break it up into smaller pieces or smaller factors. So we're just going to follow this step by step and do what it says to do. A tells us to circle 5 of the bunches. So only 5. 1, 2, 3, 4, and 5. There's my 5, okay? Y'all see? I hope, yeah, you can see that. We circle 5 of the bunches. What multiplication equation can you write to find out how many carrots are just in these 5? Well, in each of these 5, we have 3 carrots, don't we? So if I was only doing those 5, my multiplication equation would be 5 times 3. Now, B, they want us, I'm going to use a different color. They tell us to circle that one bunch that's left. There's the one group that's left. What multiplication equation would I use for that one? Well, I would say 1 times 3, wouldn't I? Because there's only one bunch of carrots. So this is what they've done, third graders. They've taken the factor of 6. Now, when I hold up and make 6 with my hands, I end up having to use 2 hands. I have 5 and 1. That's what they did. They took our 6 and they split it into 2 smaller factors of 5 and 1. 5 and 1 make 6, so I can still split them and pull them back together. That's how the distributive property works. So look at C. Look at our 2 sets. We have our 5 in red and our 1 in blue. Explain how you can use those 2 numbers to find the total. So what would we do? Well, let's go back. I can say 5 times 3, right, and get 15. And then I can say 1 times 3 and get 3. And then what I would want to do is put those together to make 15 plus 3, which is 18. Now, as the distributive property, go ahead and write this. This is an intro. The distributive property looks like this. We started with 6 times 3. Then we broke it up. We broke it up into 2 separate problems. We broke it into 5 times 3 plus 1 times 3. And that's how we got our final answer. Both sides are going to equal 18. 3 times 6 is 18. 5 times 3 is 15 plus 1 times 3, which is 3. And 15 and 3 also gives us 18. This is just an intro to the distributive property. That's what we're going to be doing to the rest of today and then Monday and Tuesday. We're going to be doing our distributive property. Let's keep practicing. Let's go to page 27. We're going to do a lot more practice on this because it's new. You can break apart numbers to help you figure out multiplication problems, right? That's what we're talking about, breaking up numbers into smaller numbers. Ty did not know what 6 groups of 3 were, but he knew what 5 groups of 3 were, and he knew what 1 group of 3 was. So he broke a 6 into 5 and 1. He did 2 smaller problems, and then he added them back together. He did 5 times 3 and 1 times 3, and then added them back together. In an array, this is what it would have looked like. I'm going to redo this because I want you to see this. His original problem was 6 rows and 3 columns, right? So this was originally what his array looked like. But what he did is he split it into 5 and 3 and 1 and 3. And he got 2 small answers, which were 15 and 3, and then he added those back together. So he split a big array into 2 small arrays, and then all you have to do is remember to put them back together in the end. So now they want us to do it again, but they want us to do it if he had 4 carrots instead of 3. So again, our original problem is going to be 6 times 4 equals. We're going to break our 6 apart into 5 and 1. Y'all see how I did that? Just spread my hands apart. So we're going to split it into 5 times 4 plus 1 times 4. Now my 6 didn't go anywhere. 5 and 1 is still 6. All I did was break it apart into 2 smaller numbers. We can all count by 5s really well, and we definitely know how to multiply by 1. So when we split those apart, it makes it much easier for us if we don't remember our 6's. And then we work it out. 5 times 4 is 20, plus 1 times 4 is 4, and 20 plus 4 is 24. Guess what 6 times 4 is? 24. So breaking it apart, just remember I can break them apart, but I've got to make sure I add my answers back together. We're going to keep practicing our distributive property. Let's go ahead and flip over to page 22. You're going to see some more. You've got an equal group picture where they have broken it apart into 2 smaller factors. Let's see if we can figure that out. I see 4 flowers, 4 flowers, 4 flowers, 4 flowers, 4 flowers, 4 flowers, right? So we know they've got a 4. So this first section is showing us 4 groups of 4, or 4 times 4. The second group is showing us 2 groups of 4, or 2 times 4. So they broke it apart into 4 and 2. Let's see what 4 and 2 give us. 4 and 2 make what? 6. So they took a 6 is what they did and broke it apart in a different way. So what we're going to do is answer them and then add them back together. So this is what this problem looks like. 4 times 4 plus 2 times 4. 4 times 4 is 16 plus 2 times 4 is 8. And 16 plus 8 would give me 24, right? Because 6 times 4 is 24. So this would equal 24 total. I'm going to write that down just so we have it. Now you could also do this as an array. Look at our array down here. They started out with 1, let me change that, 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 6 times 4. But then what did they do? They started with 6 times 4. They started with 6 times 4. And then what they did? They broke it apart. You see where this is split? They split it into 1, 2, 3, 4 times 1, 2, 3, 4. So they split it into 4 times 4 and 2 times 4, right? 2 times 4 and 4 times 4. Still going to get the same answer. 4 times 4 is 16. 2 times 4 is 8. And 8 and 16 is 24. And 6 times 4 is 24. We're still going to get the same answer. So let's look at our solve it here. Oops. Wrong button. Here we go. It says 6 vases of 4 flowers is the same as 4 vases of 4 flowers plus 2 vases. So this is how I want you to write this down here. I want you to write 6 times 4 equals. So now we're going to take the 6 and we're going to break it apart into 4 times 4 plus 2 times 4. Now I want you to see that 6 is still here because 4 plus 2 is 6. We didn't take the 6 away. We just moved the 6 into 4 and 2. That's how we made our 6, 4 and 2. All right, let's try some on our own now. The next page, this will be our last page for today. This is page 23. Number 2. What numbers did Mario break 6 into? He broke 6 into what? 4 and 2. So 4 and 2. Change that color, y'all can see it better. He broke 6 into 4 and 2. Number 3, what two multiplication equations? Well, when he broke it apart, he still had to say 4 times 4. He had to give everybody 4 and 2 times 4, right? He had to give everybody that times 4. What's another way? How else could we break up a 6? What did we do on the last one? How else did we break up our 6 on the last one? 5 and 1. How else could you make 6? What about 3 and 3? So there's lots of ways. We could do 5 and 1, or we could do 3 and 3. Can you think of any more? 2, 4, 5, 1, 3 and 3. Of course, we could always swap those, couldn't we? 1 and 5. That'd be the same thing. What numbers could Mario break a 4 into? Did you think about how we could break 4? We could break 4 into what? 1 and 3, or 2 and 2, couldn't we? Those are all the ways we can make 4. 1 and 3, or 2 and 2. Those would make 4. What two multiplication equations would Mario use if he broke it apart the 4? So which one do y'all prefer? I kind of like the 1 and 3, don't you? So I'm going to use that one. If I decided to break up the 4, now I've got to keep my 6. So I could say 1 times 6 plus 3 times 6. You can't break apart both of your factors. You can only break one of them apart. So we could either break up the 6. Why did it stop?